Hey everybody, welcome. My name is Caleb, and this is your introduction to Phoenix, which is Elixir's web framework. So if you want to build websites using the Elixir programming language, this is the video for you. We're not going to assume too much prior web development experience, but I do recommend you first check out the Elixir video I did. This is going to give you everything you need to know to understand the Elixir language. This video is going to be focused more on applying that to building the backend of a website. So if you want to build an API, or if you're just completely new to web development and you have no idea what I'm talking about, that's totally fine. This is a great place to start. Before we get started, I just wanted to mention two quick things. The first one is if you're interested in a general introduction to software development as a career, then I have an intro course that you can get for free, and this will give you a good idea of the software development landscape, different specializations you can consider, what to study, and how to get a job in the software industry. So I'll leave a link to that down below, as well as a second link which will allow you to get this video and many of the other videos on my channel for free, downloadable, and ad-free. So if you want to watch these videos offline or just have a nice organized structure for all of my larger videos without interruptions from YouTube ads, then I would highly encourage you check that out. That's my two main things I wanted to share with you, and now I want to get started. So where do we even begin? Let's first talk about some of the main concepts before we jump into code. What is Elixir Phoenix? Now, Elixir is the programming language. Phoenix is the web framework. So Phoenix basically gives us a lot of tools built on top of Elixir to build web applications. Now, typically this is going to be used to build the back end of applications. So when you visit any website, I'm just using this one as an example, you will see a nice visual of data. This is the front end of the application. Whenever you visit another page, all of the data is fed to the front end from a back end. So what looks like a single application is often split up into at least two components, the front end and the back end. Those are two general categories, but for large applications, it could be a lot more complex than just two individual things. But getting started, that's pretty much all it is. So the front end deals with presenting the data. The back end deals with providing the data. So if the front end makes the data presentable and you can interact with it, what exactly does the back end do? It gives us that data, but where does it come from? Typically, it'll come from a database. An example could be SQLite or Postgres, MySQL. There are a ton of different databases out there. We have videos on all kinds of different database topics on this channel as well, if you're interested. So the backend just takes the data from the database and gives it to the front end in a predictable way. And that is through the use of JSON. JSON is a data notation. It's how we can represent data in text, and I'll show you an example of that. So here is an example of some JSON data. You can see this gives us data about some population metrics. And you can see it has the nation and then the population. So when you receive data in this JSON form, it's coming from an API. So an API is just a backend that will allow you to request certain information and retrieve the information in JSON. So that's the general overview of the architecture for a web application. You have the front end, we've talked about that a little bit. We're not going to get into that too much in this video, just a little bit. Then we have the back end. The back end takes data from a database and gives it to the user in JSON format through an API. So by the end of this video, you should have a working API which takes data from a database and displays it in JSON format. So now we have a good understanding of the overview, but let's zoom in a little bit more, because when you build a more complex application, you need a way to organize your code. And there are various approaches or design patterns to do this. One of the most common is MVC. So you definitely want to understand this acronym. It basically will split up your code into three sections: the model, the view, and the controller. The model's job is to basically be the data layer, interact with the database, and give you data in your application. The second thing is the view, and this deals with the presentation of the data, displaying that data to the user. And then the third thing is the controller. This will interact between both of these and basically be the brain of the application. So I have a basic diagram that'll show this. There's probably variations of this, so I'm not saying this is 100% the only way you can think about this. Essentially though, we have a user visit the application and it hits a controller. The controller will be like, oh, we're getting a request. Let's get data from the model. The model will get the needed data from the database and give that back to the controller. The controller can then ask to render a view, which will basically embed real data in a web page. That view will then be given back to the end user. Now, in the context of building an API, the view might not be a web page like an HTML page. You can think of the view then just as the JSON structure, or you might be able to design this without a dedicated view at all. In general, this is the pattern we're going to follow and is recommended by Phoenix. Here is another example diagram, but this one is a little bit more specific. Instead of just the categories, we're going through an example. And this also introduced a router, which is basically a layer that will associate some request to a function in a controller. And we'll see all of this in detail, so don't feel like you have to have it all memorized and understood 100% right now. And you can see that this is typed to users. So this is all about users. We have a users model, which will grab some user data. And then we can render a specific view about a user, such as their profile. This takes that MVC concept and makes it a little bit more concrete. So hopefully this was helpful. Now that we have an understanding of the basic concepts, we can actually start working with Phoenix. So we'll start by installing and then generating a basic project. To install, we will be using Hex. Definitely check out the prerequisite Elixir video if you are not at this point yet. So we'll say mix local.hex. I currently already have this installed, but you can go ahead and go through this process. And then we'll say mix archive.install hex phx new. And this phx new will give us a command to generate a Phoenix application. And again, I already have this installed. Now, the basic way to generate an application is mix phx.new and then the name of the application. I'm not going to run this quite yet because I'm going to modify it slightly. This command right here will assume that you want a database and that you want that database to be Postgres. Phoenix uses something called Ecto to work with the database, which is an ORM, and we'll explain more what that means. But basically, the database you choose is not a huge issue when it comes to application code. So if you're using Postgres, but I decide to use SQLite, the overall code is going to look pretty much the same. It abstracts away a lot of the database specific stuff. I'll use SQLite 3. It's just an easier database to get started with. So I'll say --database SQLite 3. If you don't want a database at all, you can do -no-ecto. But I do want a database, so I'm going to execute this command. Fetch and install dependencies, we'll say yes. Alright, that's finally done, and it gives us some follow-up steps. We will open this new directory in an editor, and I'll open a terminal from here. So the first step we will do is configure the database. The default configuration is fine, so I will just run mix-ecto.create. Mix-ecto.create. I'm going to zoom in just a little bit here. And this will set up the application and database. You can see the forum dev.db shows up. And now we can start our Phoenix app with mix phx.server. We'll run this, and this will open an application on port 4000. So you can hold command and click or control probably on Windows, and you'll see a landing page for your website. Congratulations, you just launched your first Phoenix website. It's still local and it's pretty much nothing, but it's a start. You can modify the configuration for this application inside of config dev.exs. So this will allow you to do things such as change the port or various other things. So now we know how to start an application. Let's talk about some of these files because it generates a lot. I'm going to give you an overview of where to find what so you have an idea of what you're working with. First, let's talk about some of the hidden directories or things prefixed with an underscore. So a hidden directory starts with a dot and typically means that you don't usually have to go in there and tinker with stuff. This is usually for configuration files or build files or anything like that. So we have an underscore build. This is where when you run your application, all the build artifacts go here. They can be removed as they are generated on the fly. Similar idea for Elixir underscore ls, just files that you don't need to tinker with. This is related to the Elixir language server, which I have an extension for. So if you search Elixir, you'll see Elixir ls right here. I also downloaded Elixir formatter. Then we have another hidden file in here, .gitignore. This is one that you would typically go in and edit if you needed. This will basically configure your Git repository on what files you don't want put into the repository. For example, you don't want to put the build artifacts in your repo. Your repo should really just be for source code. And then lastly, we have .formatter. and this describes some of the configuration when you run mix format. So if you want to run commands, you can open a new tab right here, and that'll keep your server running, and now you can say mix format. This is a way to basically format your source code, which is what that extension I showed you should do for you when you save. So if you see my code jump around a little bit as I'm going through this, it's probably just because I have mix format running on save. So that was most of the hidden stuff or build artifacts. Now let's talk about some of the main files, such as mix.exs. This is the project file, and it's basically describing your project. If you've worked with Node, this is basically your project.json, containing all of your dependencies and configurations. You can scroll down and you can see your dependencies here. So by default, we have a lot of them here. You can add new ones to this list or modify versions, and then you would just say mix deps.get. You may need to do that when you first get a new project. If you say clone it from GitHub, to make sure you have all of the needed dependencies. These dependencies retrieved will be written down in mix.lock, which locks into a specific version, which can be helpful if you want to make sure everybody's on the same version of dependencies. As dependencies get updated, different things in the code could change, and if you and another developer working on the same project have different dependency versions, then the code might not work exactly the same way, or it might not compile on one of your machines. Let's talk about a couple of other things. We have assets. This is front-end junk, pretty much. You can ignore that for now. You have config. I'll let you guess what that's for. Then we have deps. These are the actual code for the dependencies. So this file contains the versions, but the actual code downloaded goes in this deps folder. There's probably a good chance that this is not put into the repo, so it's currently in the git ignore. And you don't put it in the repo because the end user that clones your repo can just retrieve all of those dependencies with the command I just showed you, mix.deps.get. Next up, we have this priv folder. These are any accessory files that are not directly running your application, such as any scripts or things you need to keep in here. This will also have things like our migrations, which we'll talk about soon. Next up, we have test, which will contain various tests for our application. Probably not going to need that. And then finally, probably the most exciting is the lib directory. This contains our app code. This is the main directory you're going to be working in to build applications. So we've talked about all the main files and directories. Now we're going to start building things out. What I like to do when I first create a project is commit everything into a repo. That way I have an initial commit, which is basically a fresh application if I need to revert back. As you're learning, I would encourage you to do this as well. Also, I'll be able to easily push this code up to GitHub so you can access it. If there's something that's not working on your machine, you could check against my repo to make sure you have the right code. So to get started, we'll say git init. Obviously, you'll need to have git on your machine. So if this doesn't work, you will need to go get git. Then we will add our current directory, and we should be able to say git status and see all of these added files to the staging area. And then we can say git commit -m for message, and then we'll just say something like init. Cool, so we have a repo, and now we can see our commit history here with git log, so we can track changes a little bit easier. Now I will push this repo up to GitHub so you guys can use it. So from GitHub, I'm creating a new repository. I will call this Elixir Phoenix. I will make this public and then create repository. And then I already have a local repo because I just created one, so I will copy these lines here. Paste those here, and then this should now be available on GitHub, so if I do a refresh, I can see all of my code here. And it also defaults with a README showing how to get set up, so you can use mix setup to install and set up dependencies as well. And then as I make changes, you'll be able to see these in the commit history. So you can go to this exact moment in time and see what changes were introduced. Okay, cool, but this isn't a tutorial on GitHub, so I'm going to end there and get back to our application. So first off, we know we can reach the default page. This is a page available on our application. So I want to show you where we can find what pages are available to visit. That's in the router. So to find that, we'll open our files into lib, and then under forum web, there is a router.ex. This is going to describe the available paths, and you can see this path right here. So when we have get with just a slash, that means just the home page, nothing additional. And this is going to use the page controller and render a page called home. So we can basically follow through to see what this is doing. So we'll go into controllers, and we can see page controller right here. And here is the function home. And all this does is invoke a render and display the home page. Okay, cool. So we see that connection, but how do we actually see the home page? You can find this under the page_html folder, and then there is home.html.heex. And we'll open this. There may be an HEEX extension you can use if you do not get highlighting. So this is our actual page being displayed. Obviously there's a bunch of stuff in here because it's a pretty complex homepage. We could actually just replace all of this with an H1 saying hello and welcome. And then we will close the H1. Oops, I guess it did it automatically for us. Now when we do that, let's take a look at our server. Anytime we save, we will get this to rebuild, so we don't have to stop and start our server every time. It'll do it for us automatically. Now when we visit the page, it says hello and welcome. So that's how you modify the homepage. You know exactly where to find it now. If you're new to this, it might have seemed like a lot of jumping around, and it is. Let's just go through that process one more time. We first hit the router. This will take a request and associate it with some controller. The controller will do any application logic. In this case, all it did was render a page, and that page was the home page, which we modified, and that's what gets sent back to the user. It pretty much followed this structure exactly, except we didn't have a model since we're not working with any data. So we just hit the router, the controller, and then the view, and that's what's sent to the user. So now we understand the basic structure for the existing page, but now I want to show adding a new page. How would we build out that structure? We're going to start with mocking some data, and then we'll talk about how we can generate a model and do all that fancy stuff here soon. So mocking, we basically are just going to hard code some data, and then we'll learn how to substitute that for actual data from a database. So we'll basically just follow that same workflow, starting with the router. So we can go in here and create a new route, let's say /users, and we can just use the same controller. Sometimes if your application is larger, you might have a dedicated controller, such as a users controller. And then we'll just say :users. Then we'll go over to the page controller. We'll define a new function here. It's going to look pretty much like the same thing. So we'll have _params do. And then inside of here, we will say io.puts and then some message users function hit, just showing you this so you can see how to have stuff show up in the terminal. And then we will invoke render. This will be pretty much exactly the same as this up here, so we'll pass in the connection. We'll say the user's page. And then for the layout, you can do layout is false. A layout will allow you to have similar things across multiple pages, such as a header or footer, but we'll leave that off for now. And then we'll just create that page. So under page_html, we'll say users.html.heex. And then in here, I'll just create an H1 users page. This should be ready to go. So let's check out the browser. You should now be able to go to localhost 4000/users, and we get users page. And then we should be able to see that in the terminal. So users function hit. And if you wanted to see what the layout looks like, you don't put layout true, you actually just take this off, and then you'll see this default layout with some buttons and stuff at the top. So that's how a layout works. But I'm going to put that back for now. Now, if we want to mock some data, what we could do is say users is a list, and in this list we will make a few maps, ID being 1, name, Alice, email, alice@email.com. And then I'll copy this, paste it again, and we'll change the data. So IDs 2, Bob, and Bob. All right, so far so good, but now this is just mock data. Eventually this will be replaced with actual retrieval of data. But either way, we need to figure out how to take users and pass it to the view. To do that, it's really easy. You'll just, after the page, say users is users. And then over in our view page, we can do some basic display of user information using the template engine. So the template engine for Phoenix is called Embedded Elixir, or EEX. And it allows you to do basic formatting of Elixir code that'll eventually be turned into just HTML. So you can read about all the in detail syntax guides and stuff on that, but I'm just going to go through a very basic example. We're not going to be using this long term, so I usually don't spend too much time studying the template engines. So we'll just do some very basics here. For user at users do, we will surround this actually in an unordered list. So I will put that up top and then close it down here. And then for each user, we can create a list item. And then to end the loop section, you will use less than % and % greater than. And then inside of the list item, pretty similar idea, user.name % greater than, and then we'll just do a hyphen, and then the same structure, user.email. So hopefully I got this structure right. Don't worry if you don't understand all the details of it. This is honestly the last time I'm going to use it in this video. But the general idea is that we need a way to indicate when we are using Elixir code. That's why you have all of these symbols like this. So we go over to the web page and you can see it shows up with Alice and Bob and their information. And if you right click and say view page source, you can see that the destination is purely HTML. There's no Elixir code or anything in here. Basically, this HTML page is generated on the backend, and then the backend sends the final HTML page to the client. Because it's all done on the backend, we're able to work with data that's being sent to this view. This is one way of building full stack applications, but it has its limitations by default. First off, you're using some very niche templating engine, which if you have simple applications might be fine, but if you're building out complex front ends, it might not be ideal compared to using a front end framework like React. And pretty much by default, anytime you visit another page, it's going to do a page refresh, so it's really not friendly for single page applications. I wanted to show you how to build a very basic templated page, but I'm not going to be using it for much more than this because ultimately I want to return JSON instead of an HTML page. But it's worth knowing that the backend can do either. You don't technically have to have two applications, a backend and a front end. They could all be within a single application, and then that backend would just give HTML. So now at this point you understand the end-to-end to create a new endpoint, and this endpoint is currently returning HTML, and we're mocking data. So the two things we need to update is use real data and return JSON data. Let's first conquer the returning JSON data. We can use that with mock data just the same, and then we'll talk about how we can start introducing the model, working with the database. Giving JSON back to the user is very easy. We can replace this call to render with JSON, passing in the connection, and then a map containing users being the user's data we have up here. So this is the key, and then the value is the actual data. Now when we visit this page, we get JSON data instead of an HTML web page. Cool, so there you go. That's how you create JSON data. Now let's move on to the next big challenge, which is how to start working with a database. Probably the easiest way to get started working with the database with Phoenix is to actually generate some code. We have a few commands available to us, which can give us the starter code, which we can then adapt to our needs. So just ignore the user stuff for now. We're going to build out an example for posts. Say we were creating a forum, we want the user to be able to post information. So if we wanted to generate some code for that, we will open a terminal and say mix phx.gen.json. And then we're going to say posts, capital P, post, no S, capital P, and then posts with an S, lowercase p, which is a little confusing, but I'll explain it here in a second. What we can do is then define some types. So we'll have a body and a title. These are both going to be strings. So the user can create a post containing some information, including the title and the body of the post. Okay, so what are these three posts doing here and what do they mean? The first posts here is the name of the context, which is typically responsible for encapsulating data access. So you can kind of think of this as the model part of the MVC, but it's also going to be paired with a schema, which is the second post here. That's the schema, and it basically describes the structure for what a post looks like. The next is going to be the entity plural, which is going to be used for the table name. Running this will create a bunch of files and then give you a command to add it to your router. I'm currently in router and I want to do what they're asking, but I'm going to do it slightly different. And I'm going to show you how to create the API to be under /API in the path. So we will create a new scope here, and this will be /API. And then for web do, and then I'll copy this line here that they recommend, paste that here, and we'll prefix this with pipe through :API. This will allow us to set up middleware later. Next thing it says is to apply your migrations. So run migrations, and it says mix ecto.migrate. What does this mean exactly? Well, as we change the database structure, we create migrations. This will show us how to go from nothing to creating the data structure we've developed over time. So this is going to be a basic migration that describes creating a table for posts that has a title and a body. So you can see that migration over in files, and then under priv, repo, migrations, we'll see this new one here, which is called create posts, and it describes a change to the database of creating that table. This describes a change to the database, but doesn't actually apply them until we run our migrations, which is exactly what it's telling us to do. So down here in the terminal, we'll say mix ecto.migrate, and that'll run the migration and change the database. Now we should be able to, with a running server, visit the web page and go to /API/posts. And you can see we get data with an empty list. And this is exactly what we want to see. So if you see this, it means it's working. The reason it's not showing anything is because we don't have any posts yet. So let's talk about how we can create a post. To create a post, we're going to use a tool called Postman. And maybe bad choice of example here, but the post in Postman does not relate to creating posts on a forum. Instead, it's referring to a post request, which is how you make a request to an API to add new data. So you can get Postman online, or you can use various other API testing tools if you're comfortable with them. So just search Postman and get this platform. And I download it, so I have it on my computer, but they do have an online version. However, since I'm working in localhost, it's easier just to run the local version. So I'll open Postman. It'll look something like this when it opens. We will create a request to http:// Note there is no S, localhost :4000 API posts. And then we'll change the method to post. Then we'll go to body, raw, JSON, and we can structure what a post should look like in here. And you're going to start with an outer key. So post, and then you'll have an object associated with that. So we'll have a title, and this is basically just key value pairs, my first post, body, and we'll just say, let me tell you about myself. We hit send, and it gives us back the same thing with data and ID 1. The ID comes from the database and acts as a confirmation of the insert. So you should now be able to go to the GET request from the browser, do a refresh, and see that data. You can of course also make the request from within Postman to receive the data. So this just works. So all the generated code does exactly what we expected. Let's take a look at what it's actually doing though. Following the path from the router, we go to the post controller, which is right here. We then have a create function, and we'll talk a little bit more about the function structure now. So we have the con, we've seen that. This contains information about the request. And then the second parameter is what we actually care mostly about right here. This is pattern matching, which will take a map with a post key, and the value associated with that will be assigned to post params. So if you take a look at our request when we are making a post request, it's exactly that structure. So we have post and then some data here. This is what gets assigned to this post params with pattern matching. So if you want to see that, you could come down here and say IO inspect, passing in post params, and then when we send data, we get a new ID 2, and over in the terminal we should be able to go to the output, and here is that data. This line here will invoke posts.createPost and pattern match it with this here. And if that structure is matched, meaning it has an OK for the first attribute and then the post itself, then we will do everything here. And the actual post will be assigned to this post parameter here. Translation, the insert was successful because it matches this structure. If we want to see that structure, what we will do is we will invoke posts.createPost separately, passing in the post params, and we'll create a variable result. And then we could replace this line here with result, so it should function the same way. But now we'll have the ability to say IO inspect, passing in result, and we can also give this a label, db result. So let's insert some data again. I know I'm making duplicate data, but it's not a big deal. We can take a look at this and search db result, and this is what it looks like. So it's a tuple with the first value being okay, and then the second value being a post struct. If we wanted to put something in faulty just to test it, let me change this to tile, hit send, and it says can't be blank. And now when we search db result, we have error as the first value. That's not going to match this pattern, so this is not going to happen. Okay, cool. So we have a better understanding of what's going on up here. Down here, we're just preparing the response, putting in some headers, as well as the status. So if you take a look at the status, it's okay, that was a bad example. So hit send, and we can see 201 created. So that's coming from put status here, and then we have the headers, and then we render, and this is actually rendering a template, but that template's ultimately going to give JSON, but it is possible to put that in separate files, as we've seen here. So you can see that in post_JSON, and we see show right here. This basically allows us to separate some of the view logic, and you can think of the view here as JSON instead of HTML. Totally fine. And this basically just makes a key data and then puts the data. So for example, if we change this to post and we hit send, that would change the key to post. So that's how you modify what the response looks like to the end user. There's also a way to render a list of posts, so you could change that to posts. So now when we get all of the posts, we just see posts. So conclusion, you can still think of posts_JSON as the view layer. It's just giving us JSON directly instead of a template containing HTML. A lot of this was generated by default, and if you want to get a good overview of the routes that are available, you can go look through the files, or you could actually say mixphx.routes. And a lot of these are created by convention. So to get the posts, it's going to be called index. To get an individual post, it's going to be called show. And then we have create, update, 2 updates actually for patch and put, and then delete. These should pretty much be already wired up, so if you want to get a post by ID, you can invoke post/ and then pass in an ID value, which is what that colon means. You pass something in. So we get API post/1, and this gets us an individual post with the ID 1. So we've talked about getting a list of posts, we've talked about adding a post, we've talked about getting an individual post, and now I want to talk about updating and deleting posts. As we saw, there are 2 different things here for updating. There is patch and put, and these both do the same thing. So you're going to get the same functionality for both of these methods. But in general, the difference between patch and put is that put will replace a resource being whatever you're trying to work with in the API, in our case, a post. And patch will just update a resource, meaning if you don't include any attributes, it's just going to keep what they originally had. By default, both the put and the patch capabilities in Phoenix are going to act as a patch. So I'll show you exactly what I mean. So if we go over to our request and we say put, and we want to change the post with the ID 1, we could say my first post updated, hit send, and that update worked. If we remove one of these attributes, and we'll change this again, so post updated again, we hit send, you can see that the title changed, but the body stayed the same. So put is not really replacing the data, it's just updating whatever data we want updated coming from the body here. Because of this, it's not really a replace, it's more of just an update, and it actually matches the behavior of a patch more closely. So if you're going to be working with updating data, I would use the patch method. And if you wanted, you could create a separate replace function to replace data using put. And in that situation, because we didn't include body, it would remove it from the object in the database. I think the default behavior is fine. I'm just going to opt to use the patch method when I make an update request, just for clarity and to avoid any confusion. Again, if you wanted to implement a separate put capability that would actually replace the resource, feel free to do that as an exercise. Now let's talk about delete, which is super easy. This is about the only thing I'm good at. So we'll just go into delete, hit send. We should get a 204 no content. So that's a pretty common response for a delete where we don't actually get a body. And then the next time we should get a 404 because the thing we're trying to delete no longer exists. So 404 not found, saying, hey, we tried to find the post you're trying to delete, but it doesn't exist. And that is general CRUD capability: create, read, update, delete. Congratulations, you now know how to generate small APIs for different resources and work with that API. Now you just need to learn a little bit more to learn how to make changes to the default structure to match whatever you need for your API. That's pretty much what we're going to talk about next, because I'm going to introduce users where the user can create a post, and that post is effectively owned by the user. This is introducing relationships, which is an essential thing to understand, but it does get a little bit more advanced. So maybe what we've covered so far is good enough for what your needs are, but if not, then I encourage you to continue watching through this next section. It gets a little bit more intense, but really not too bad, because I'm going to make it super simple for you guys and tell you exactly what you need to do. So let's get to it. So we're going to talk about how we can update our existing models and create new ones. So what we'll do is we'll create a user schema and use this as the owner of posts. So this will be pretty similar to the command we ran earlier, which is this right here. So let's say we want to generate a context for accounts, and then the schema will be user, and then the actual database table will be users. The user will have a name, which is a string, and an email, which is a string, and you can also include other attributes in here such as unique. We'll run this, and right before I did this, I created a new commit, so now we can easily see what files were added. So that's a good strategy to see exactly what this command is doing. I don't want to get too distracted by looking through those, so let's just go back to what we were doing and take this and put it inside of our router so we can include that here. Now I know we were kind of working with a basic users example earlier, but that was just for basic demonstration purposes. I'm just going to remove that. And then we have this migration here, which creates the table for users. So to apply this, we'll say mix ecto.migrate. Cool. So we got that applied. We should now have a table for users. But how do we associate a post to a user? For that, we can change the existing structure in the database that already exists for posts by adding a user ID. So to do this, I'm going to create a new migration. But first I'll say git add, git commit, created user migration. So now we can see any of these changes and we can go back if we need. So to create a migration, we'll say mix ecto.gen.migration, and then give it a name, something like add user ID to posts. And this created this file, but you'll find that when you open this file, it's pretty much empty. It doesn't know what to actually do, so we'll basically describe these changes here. So add user ID, references users, and then on delete, we'll say nothing. So this describes our change, and then we can apply this with mix ecto.migrate. Cannot execute command outside of block. I need to do one additional thing, which is actually surround this with alter table, which is kind of important. So yeah, don't forget to do that step. So we'll build that structure to alter the table, and then how we're going to alter it is by adding the user ID column. Now we should be able to say ecto.migrate. That should have changed the database, and now we can assign a user as the owner of a post. This changes the database structure, but it doesn't change the schemas in our code. So if we go into forum and then into posts, you can find post.x. And this is the post schema, how we will interact with posts in our code. There's no mention of a user ID or an owner here. So we need to make the association not only in the database, but also in our schemas. So this is going to be done in 2 steps. The first will be in the post schema, and then the second step will be in the user schema. So you can see both of these right here. So in the post schema, we will add a new value here that says belongs to, and this will belong to :user. There's no colon after the belongs to, but just here as part of the atom, and then a comma, and then the actual location of this. So forum.accounts.user. So this is the application, then the context, and then the schema. Save that and it works. And then we'll do the same kind of association over on the user's end, which will be slightly different. It'll be has many, and it'll be called posts. And this is going to come from forum.posts.post. And you can see those up here at the top. So forum.accounts.user and forum.posts.post. So far, so good. So we made the association in our code, which will allow us to refer to the user's posts in our APIs. So to test out nested data and API calls, we will first need to create a user. The user is going to own the posts. So head over to Postman, and I'm going to make a new request just so we can keep this one open. So this one is going to go to API users, and the method is going to be post. We'll go to body, and we'll say user. The user will have a name. We'll just give it some name like Caleb. And then, I believe, an email. All right, we'll just come up with some example email that matches this structure here. So name and email. We'll hit send, and we get a response back with ID 1. So we created a user successfully. Now, if you immediately want to go and create a post with this user, so we'll say post to the posts endpoint, a title, and then a body. And then you wanted to include, say, a user ID, which we need to quote user ID of 1. This is not going to work by default. So when we hit send, it creates the post, but the user ID does not actually get attached to this request. There is a data structure in the database, but there's also application level validation, and we need to take a look at that. So if we go over to post, we can see this change set function down here, and it only takes a body and a title. So we can just add into this a user, and this would actually be user ID. And now the user ID is actually going to be required. So we hit send. It still doesn't show up here, but if we remove it and hit send, which actually I got to remove this comma, hit send, we get an error saying the user ID can't be blank. So now it's actually going to the database, but it's not being displayed when we request the post. Over in Forum Web, we can go to post JSON, scroll down to the structure being returned for a post, and we can add one in here with user ID, post.userid. Now when we create a new post, let's add in a user ID here. So user ID is 1. Hit send, and we can see that the user ID comes back and it has the value 1. We could also retrieve the posts and see that for some of those that didn't return a user ID, they still got assigned a user ID. So you can see that last one we did right before the one we just did. The user ID was given to the database, it just wasn't being returned back in the API call. The ones prior to that, the user ID was not even being delivered to the database. So there's basically two components. The first is in the view, structuring what we want shown back in the API, and then the schema, which defines what we actually want to be given to the database. So there's two pieces there. And none of this requires any migrations or changes to the database because this is purely changing how our application works, not our database structure. Let's go through an example. If we want to get a user's post, currently we can get the user, but the posts are not included in this response. Let's talk about how we can add a list of posts. This is partially a display concern because the relationship exists in the database, it's just not being returned here. But there is one additional step we need to do on the code side, which is to actually preload the posts. Related data is not going to be retrieved by default because if you're just wanting to get the user information, it might be a waste of resource to go collect all of the user's posts. Especially if it's a complex database with lots of relationships, you're not going to naturally go to all these other tables and search for the user ID. So instead we have to be explicit and say when we want to load some of those relationships. You do this in the context, so you'll find that in lib, and then in forum, the application name, and then the context, which is called accounts. We have the ability to list users, returns the list of users, and then get a single user right here. So if we want to also load the posts, we can just pipe this to repo.preload, passing in posts. That deals with retrieving the data, but we also have to have that data displayed. That's going to be a concern of the view. So we'll go over to the view inside of user_JSON, and where we render a single user, we can modify this to include the posts. So we could say posts, and we'll start with this, but it's not 100% correct. So we say user.posts, and then let's say we wanted to retrieve a specific user such as user1. We get an error, undefined error, and that's because we can't just immediately display a list like it's an attribute here. There might be an easy way to do that, but I'm going to show you what I know, which is basically to copy the pattern they have here. So when you want to show multiple pieces of data, you will loop through that and then invoke data for each one, giving this structure. So we could kind of copy that behavior. We'll just copy this function and then paste it here, and I'll call this post data. We'll be working with a post, and we'll change this to post, and then we'll get the post ID, the title, which will be post.title, and then the body, which will be post.body. Then we can remove this last one here. And then I just need to add in a comma there. Okay, so it says the post struct is undefined. We just need to alias this. So we'll say alias forum.posts.post. This is just a way so you don't have to qualify the entire name when you want to use it. So now we can just say post directly. And then we'll basically do the same behavior here for posts that we do up here. So it'll look like this. For post user.post. So for each post in the post list, do, and then we'll call post data, passing in the post variable that we defined here. And that should do it. It's basically going to iterate through each post and give us a structure that looks like that. So now when we get this user, we get all of the user information and a nested post with a list containing multiple values. These are just duplicate posts because I posted it a few times, but that's fine. If you posted anything new, it would show up here. An alternative approach to matching this exact structure would be to just reuse this function, but from the post JSON. So you can see it has something very similar here. So you can just remove the P for private, so it's available to use over in this file. And then instead of post data, you would just say forum web.post JSON.data, passing in the post. This currently says it's undefined. I think it's just a typo in what I have over here. So JSON, this basically will match this here. So that should do it. And then we could, in theory, just remove this one or comment it out. And we run, and we get the same result. This time it actually includes the user ID, because that was a slight difference between the function we just created and the function that was already defined. I wanted to show you a couple last little things. First thing, we could alias this so we don't have to qualify it. So alias forum web.post JSON. And then down here we would just have post JSON.data. And an alternative approach to doing this here would actually be to use enum.map. And this will take the list, which is user.post, and then a function which we can capture postjson.data/1, and that should do the same thing. That'll return a new list of data, and it looks exactly the same here. We have covered a lot of ground, and that's pretty much where we're going to end this video. It gave you a good foundation, gave you some of the things you need to know to start working with Phoenix. Clearly, there's so much more we could do. For example, you could have the user register and log in, and then they'd only be able to create posts for themselves. That's a simple thing you could try to implement. My intro to Elixir video and this Phoenix video is the first time I've ever done anything with Elixir here on YouTube, so I'm hoping this video does well and it's very helpful, but I'm really unsure what you guys are hoping to see next, so definitely drop a comment down below letting me know, and if you like this content, be sure to subscribe and hit the notification bell as well. Thank you so much for supporting this content. It means the world to me. I will commit these changes so you can see the latest changes up in GitHub. And just as a reminder, you can find that here at github.com, Caleb Curry, Elixir Phoenix. Thank you so much for watching, and I'll see you in the next video.